Objective 15, determine the ratio or formula of ions needed for an ionic compound, including how many electrons will be lost and how many will be gained. So if we look at beryllium and phosphorus, beryllium and sulfate, and then zinc and hydroxide. For beryllium and phosphorus, the first thing you have to do is you have to find beryllium and phosphorus on the periodic table. When I find beryllium, I see it's in family 2, so I know beryllium's going to lose 2 electrons to get stable. Phosphorus, when I look at it, is over in family 15, so it needs to gain 3 to get stable. And my board's not cooperating very much, but I'll see if I can do my best here. So when I do this with 1 beryllium and 1 phosphorus, there's an extra electron that needs to be given to phosphorus. So I'm going to have a second beryllium to make that happen, but now there's an extra electron that beryllium needs to get rid of. So 1 of each doesn't work because there's only 2 and 3. 2 and 1 doesn't work because now there's 4 and 3. So I bring in another phosphorus. And now I need another beryllium to take those last 2 electrons. So the least common multiple is for 3 berylliums to lose 6 total electrons and 2 phosphorus to take those 6 total electrons. And then that then gives me the ratio of 3 to 2, or the formula would be written Be3P2. Beryllium and sulfate is quite a bit easier because beryllium, again, has 2 that it's looking to lose. But when I look up the sulfate ion, the whole ion is SO4, and it needs 2 electrons. So now I'm going to need 1 of each, and this is going to be BeSO4. And there's no need for parentheses since there's only 1 sulfate being used. And then with zinc 2 hydroxide, the Roman numeral goes with the zinc and tells me zinc is going to lose 2 electrons. Hydroxide, when I look it up, can only take 1 electron. So I'm going to need a second hydroxide to take both electrons from the zinc. So this is going to be ZnOH. And because there's more than 1 of this group, I put parentheses and then indicate my 2. So it's really about finding the least common multiple for your 2 ions, your positive and your negative ion, because the electrons lost has to be equal to the electrons gained.